In this video, we explore a planet that may one day become humanity's second home. Here are 10 fascinating facts about Mars. Mars has been known since ancient times, simply because it's visible to the naked eye. However, ancient people didn't realize it was a planet, just a bright spot in the sky. Without telescopes, 5 planets are visible from Earth: Mars, Venus, Mercury, Saturn, and Jupiter. But from a distance, they look just like stars, tiny glowing dots. Unlike stars, though, planets move in different patterns across the sky, which is how ancient Greeks distinguished them and called them wandering stars. With the invention of telescopes in the 15th century, scientists began to understand that planets were entirely different from stars, igniting interest in the possibility of life beyond Earth. In the 19th century, Italian astronomer Giovanni Schiarelli reported seeing what he called canali on Mars, natural grooves or channels. However, the word was mistranslated into English as canals, suggesting artificial structures. This led to widespread belief that a Martian civilization existed and had built a vast irrigation system. By the early 20th century, American astronomer Percival Lowell passionately promoted the idea of life on Mars. He believed the canals were desperate attempts by Martians to transport water from polar ice caps to the planet's dry equator. These ideas captivated the public imagination and inspired countless articles and works of fiction. However, as astronomical tools improved, these canals were revealed to be optical illusions. Modern high-resolution mapping from orbiters confirmed there were no artificial structures, only natural formations. The myth of Martian canals stemmed from visual misinterpretation, mistranslation, and the human tendency to see patterns where none exist. Humans haven't yet traveled to Mars. Instead, the planet is explored using rovers and orbiters. These missions have transformed our understanding of the red planet. Evidence now suggests that Mars once had a thicker atmosphere and liquid water, conditions that may have supported life in the past. NASA's Perseverance rover, launched in 2020, represents a new chapter in the search for ancient life. Its mission is to study Mars geology and collect soil samples for future analysis on Earth. While no direct signs of life have been found, scientists have identified several environments that could have been habitable. There's also speculation that microbial life might still exist deep beneath the Martian surface. Some researchers believe that Earth microbes could have unintentionally hitchhiked to Mars on spacecraft, as even with sterilization procedures, it's nearly impossible to eliminate all microorganisms. If life exists on Mars today, it may not be native, it could be Earth life that adapted to Mars' harsh conditions. This raises concerns for future planetary missions, as spreading terrestrial microbes to other worlds could have catastrophic effects, similar to how diseases brought by European colonizers devastated indigenous populations in the Americas. One of the most debated images in Mars exploration is the so-called face on Mars. In 1976, NASA's Viking 1 mission captured a photo of a rock formation that, under certain lighting, resembled a human face. Although scientists quickly identified it as a trick of light and shadow, conspiracy theories about ancient Martians took hold. This phenomenon is known as pareidolia, the tendency to perceive meaningful images in random visual data. Later missions with improved imaging, like Mars Global Surveyor in 1998, revealed the formation in greater detail, confirming it was just a rock. Yet, public fascination with Mars anomalies persists. Enthusiasts continue scanning Mars photos for signs of pyramids, ruins, or mysterious lights, usually just natural formations or camera lens flares. Now, imagine a future where humans not only reach Mars but establish thriving colonies. This journey would push humanity to its limits. With low gravity, thin atmosphere, and high radiation, Mars presents a range of challenges. Former NASA astronaut Scott Kelly spent a year aboard the ISS and experienced muscle loss, bone weakening, and even grew 5 centimeters taller due to spinal disc expansion in microgravity. Over generations, humans living on Mars might evolve to be taller, with stronger bodies, and possibly even develop orange skin due to increased intake of carotenoids for UV protection. Radiation on Mars could accelerate DNA mutation, potentially leading to the emergence of a new human subspecies in just a few hundred years. But differences in immune systems between Earth humans and Martian colonists could make future contact dangerous, much like historic pandemics caused by cross-cultural contact. The idea of terraforming, transforming Mars into a habitable planet, has fascinated scientists and science fiction writers alike. Mars' current atmosphere is too thin to support human life, and surface temperatures average around 60 degrees Celsius. Liquid water can't exist without pressure or heat. One proposal is to create a new atmosphere by crashing comets into the planet, releasing gas-forming molecules like carbon, hydrogen, and nitrogen. But to match Earth's atmosphere, it would take over 10,000 comets, an impossible task with today's technology. Another idea involves constructing massive domes over regions of Mars to create Earth-like environments in enclosed spaces. This approach, known as paraterraforming, is more feasible with current resources and could provide habitable zones without altering the entire planet. Colonizing Mars remains a colossal undertaking. Even getting there is a huge risk. The journey itself, lasting about 40 weeks each way, exposes astronauts to intense cosmic radiation. Earth's magnetic field protects us here, but beyond it, astronauts are highly vulnerable. Apollo mission veterans, the only humans to travel outside Earth's magnetic field, showed higher rates of heart-related health issues, despite their short 2-week trips. A mission to Mars would involve years of exposure to reduced gravity and radiation. Muscle and bone loss would occur, even with constant exercise. Returning astronauts might struggle to walk, and in extreme cases, even a hug could cause broken bones. Mars' surface also poses hazards. The regolith, or soil, is fine and sharp, similar to lunar dust. On the Moon, astronauts had trouble keeping dust out of their equipment. Mars has strong winds, meaning dust will infiltrate habitats more easily. The soil is also toxic and unsuitable for growing food without advanced filtration, unlike what was shown in popular films. Psychological challenges are another concern. Communication delays with Earth would be at least 20 minutes each way, making real-time conversations impossible. Astronauts would have to rely entirely on their own team in emergencies, knowing that help from Earth won't arrive in time. So why even go to Mars? There are several reasons. First, scientific discovery. A manned mission could unlock knowledge that reshapes our understanding of the universe. Many modern technologies, like solar panels, water filters, and even ballpoint pens, originated from space research. Second, commercial potential. Wealthy individuals might fund space tourism, and one day, Martian colonies could enable resource extraction or launch new industries. Third, having a second home increases humanity's long-term survival odds in case of global catastrophes. And finally, exploration is in our DNA. Pushing boundaries has always defined human progress, and colonizing Mars would be one of the greatest achievements in history. Mars also has two moons, Phobos and Deimos. Unlike our moon, they are irregular, rocky bodies likely captured asteroids. Phobos orbits close to Mars and is slowly spiraling inward. In about 50 million years, it will crash into the planet, causing a cataclysm that could wipe out any Martian settlements. Deimos, on the other hand, is drifting away and will eventually escape Mars' gravity. That's the end of the video. Thanks for watching. Don't forget to like and subscribe to the channel.